recording.
Okay, so now we need to subnet based on need for more hosts. We saw it from the network, and remember that we talked about it being directional, that if I'm networking, if I'm subnetting based on more networks, then I'm going to move from left to right. Well, now we are going to move from right to left based on the number of hosts we've been asked for. So here's the subnet, or sorry, the IP address that we own. We own 160.12, still a Class B address. And we have been asked to create 4,080 hosts. So what we've basically been said or been told is, look, I need a bunch of networks. I don't care how many, and I need each network to have at least 4,080 hosts. Okay? So we'll start out the same way. We don't need, we're not going to be changing the first couple of octets here. So we'll put those down. Those are the octets that we're going to change, most likely. Okay. We start out Class B default subnet mask, right? We've been asked for 4,080. Remember the two addresses we're not allowed to use? We are not allowed to use either the all zeros or the all ones. Earlier when we talked about this from a network standpoint, we didn't use the zero network. So you remember we started here and we moved our line over, say, to here, and we weren't allowed to use the network that had all zeros here or all ones here. The same thing is going to apply when we talk about this from the host perspective. I am not going to be allowed to use the address that has all zeros back here and the address that has all ones back here. Remember, if it has all zeros, that's the network ID. If it has all ones, it's the broadcast. So that rule still applies. Not allowed to use all ones, not allowed to use all zeros. Because of that, I need to take this number and add 2. So 4,080 plus the 2 addresses I'm not allowed to use. I actually need to create networks for you that have at least 4,082 addresses. I know when we get in the neighborhood of 4,000 addresses, you're like, big deal, what's 2? It doesn't seem like that big a deal. It can be a big deal. If I were to ask you, create a network for me that has at least 63 addresses. The dividing line for that is going to be here. But if I add 2 to that, now it's 65. My line is now here. If you draw it here, you haven't met the requirement. So you have to add the 2. It could matter. Alright? And remember that all the stuff we're talking about right now, this is classic subnetting. So this applies for this. Classic subnetting. When we talk about variable length subnet masking, or VLSM, there are some different rules. But if I tell you classic subnetting, add 2, right? All right, so we add our 2, 4,082. What do we have to do next? What's the question that you have to ask? How many bits does it take to write 4,082 in binary? Okay, now this is what trips a lot of people up, and this is the reason I purposely grab a number that big. Oh my goodness, I can't write the number 4,082 in binary. I stopped at 128. This is 8 bits of binary. I can't write that number. I told you, I think, you just got to keep doubling that. We just have to keep going. Okay? So 128 becomes 256, 512, 1024, 2048, 4096. As soon as I get a number that is bigger, I can stop. Okay? Here's the good thing about hosts, I guess. It is not necessarily, it's not a big deal for you to know that, oh look, how do I write exactly, write out the number 4082? Because we would have to take 4082, subtract 2048 from it, go to 1, you'll follow me, converting to binary. I don't really have to do that. I just really need to know how, where's this line? If this were like some game show, and I was like, okay, here we go, we're cruising along, tell me when to stop when I am in between the two numbers where this falls. And it's here, right between 2048 and 4096. That's going to be your dividing line. So it's going to be here. That's where 4082 belongs. How many bits is that? This is 8, 9, 10, 11, 12. So it's going to take me, this is 12 bits. I'm going to move my line 12 places. So you know how to write 4082, sort of in binary. You know where the dividing line is, and that's all I really care about, okay? Now the question is, remember I said for networks, if we were going to do networks, that direction, if we're doing this from the perspective of hosts, from right to left, hosts starts down here. So I am basically telling you we need to move the line back to the left 12 places. All right, well there's 8, 9, 10, 11, 12. There's my line. Are you okay with that? That's the difference right there, done, between subnetting for networks and subnetting for hosts. From this point, everything is exactly the same. My next step, what is my new subnet mask? I got 255 plus 255. All of those are ones. 1, 2, 3, 4. Start here. 1, 2, 3, 4. What's the number above it? 240. My new subnet mask, 255.255.240. Okay? Get rid of that. Now, I am going to start counting in binary over here. Let's make our life a little easier and do this. Let's put our number line under this. Two ways to look at this. I'm either going to start counting in binary over here on the network side in these 4 bits, or do y'all remember the shortcut that you discovered? Talks about it as our magic number. Do you remember that? Let's rediscover it. Let's count up in binary. 4 bits of binary. So I've got, I start with the number 0, okay? 1, 2, 3, 4. It would keep going. I think at this point you're going to find it again. I'm not allowed to use this, right? Can't use this, so we're not going to even put that up there. So I'm going to take this, these 4 bits, and write it in right here. All the rest of that is zeros. Remember that? What, now, if we get rid of our line right here, let's remember where it goes. Now what do you have? If I convert that from binary to decimal, what value have we written? Okay? Very last bit, change that to a 1. That's the first thing you can give away. Now let's change everything to a 1 on the host portion, remember. Now what value do I have up there? What is it though?
31, I've got 12 at 31 dot.
And then if I subtract 1 from that, that's the last thing you can give away. Right. Okay? So that took care of 1 over here. Now, get rid of all this on the host portion. And on the network side of this, let's write the number 2 up here. And do it again. Put all zeros in. That's your new network ID for the second network. Okay? And what number do we have? Or not. Go for it.
160.12.32.0.
Right? Last bit, make it a 1. And I get
160.12.32.1.
I can't remember how you got 31 on the first one.
how we got 31. Okay? Put it back. I had this in the network portion here. This is network. Right? Because here's my dividing line.
And then all the other one.
Everything else, that direction is host. I took in binary, counting up in 1, I took the number 1 in binary and wrote it into my network portion. If I'm trying to figure out my broadcast address or the last usable, this would be the broadcast. All 1s in the host side. Remember, broadcast is all 1s in the host portion. 16 plus 8, 4, 2, 1 equals 31. Does that help?
Neat trick. It's 32 minus 1.
Yeah. Okay? So now what I've done,
Because 31 is a host. That 31 is a host.
now I'm
It's
good
16.
here. This is done. Now I'm going to write the number 2 in here. All of that was zeros in the host portion gives me 32. And that's the only number I have turned on right here. All that is zeros. If I go to the very last bit and make this a 1, I've still got 32.1. That's the first thing I can give away. Now if I turn all of them on in the host portion, 32 plus 8 plus 4 plus 2 plus 1 is
47.
and then 1 smaller. Okay? And back into it. Now we took care of this. That's basically your number 2 network. Let's go look at the number 3 network. Get rid of all of this in the host side, reset it. And on the network side, write the number 3 in there. If all of this is 0, what do you have? Add up. 32 plus 16 is 48. So I have 160.12.48.0, because this octet is all zeros. Increase it by 1. I get 160.12.48.1. Make all of it ones. Now you have to add 32 plus 16, 8, 4, 2, 1. What is that? I'm going to remind you of our shortcut. Okay?
You always gonna add 16 on the network.
That's exactly what you're going to do. As soon as we drew our line, it's going to run here. My network ID is always going to increase by that value. So remember, we called it the magic number. So instead of having to add 32, 16, 8, 4, 2, 1, what is 48 plus 16? What is it? 64? Is that our guess?
That's right.
I know. I
Math
have
is hard.
calculators on the computers in front of you.
What?
You're joshing me.
Okay? And now, so if this is 64, subtract 1 from that, 63.255. 160.12.63.254. Okay? Or look, 31 plus 16 is 47 plus 16 is 63. There's all these different, y'all remember in math class? I know we all go, right? Where they were, hey, figure out a way to check your work. Look for the patterns. Because this is binary, binary is full of patterns. Okay? Check for them, look for them, find them. Okay, now that we have said, look, hey, there's this pattern over here, do we really even need this anymore? We don't necessarily have to keep writing this stuff out in binary. What's your next network ID going to be? I got 160 plus 12, I'm sorry, 0.12 dot 64 plus 16, 80. What's next? Nine six. What's next?
12.
Yeah, 112, right? What would be next? You could go on forever. Well, sort of. It would go 112 plus 16 plus 16 plus 16 until you can't write anything bigger than 255, right? Okay.
That's what we balance into the next octet.
Then it's a matter of 160.12.64.1. This would be 80.1, 96.1, 112.1, and so on. This, remember, one less than this number, so 80. This becomes, yeah. Right? Now you remember? Let's jump down and say, let's do this one. 160.12.96.1. What would be the broadcast of the 96 network? One 160.12 dot, nope, 111, go to the next one, and then take one off. So yeah, 160.12.111.255. The last thing you're allowed to give away. Right? Let me show you another trick. I want to know the very last network that I'm allowed to give away. Okay? I have a choice. I could do 112 plus 16 is and crickets. Plus 16 nobody? I'm all by myself.
1.4.
One what?
1.4.
Plus 16?
160.
I could keep going, right? That's really not a lot of fun. Or, there's a couple ways to do this, right? What is the biggest number I can write over here on my network side? Well, I would fill it all up with ones, right? Oh, wait a minute. We're not allowed to give that away, correct? Okay. Subtract 1. 128 plus 64 plus 32 is 224. So my very last usable network, let me get rid of this little list here. My last usable network is 160.12.224.0. Okay? My first usable would be 224.1. But I want to know the broadcast of this. Okay, I could just write it out in binary. Or, what is this number? If before I subtracted that 128, 64, 32, 16 equals
240.
your new subnet mask, right? Take your new subnet mask and subtract the magic number. 16. 224. So the network I'm not allowed to give away is 160.12.240.0. Right? Now what's my broadcast on this one? One less. So my broadcast for this, 160.12.239.255. All zeros on the network side is the original address I was given. All ones on the network side is equal to my new subnet mask. The two things I'm not allowed to give away. Don't use the original, what we call the zero network, and don't use the broadcast network. But knowing this network lets me figure out the very last network without having to make this ridiculous list. Okay? Does that make sense?
Getting it.
Getting it. Okay. We'll let that sink in. We're going to do another